Hello, this is Team Ben Squared. This is our 4-bit ALU project. We've had to design 12 components, and we've decided to have 2 extra credit components down here, the Johnson counter and the shift rotate. We had 10 switches and 4 buttons to use for our design. So let's just start. Our first operation was the AND gate. I just used the first 8 switches here, so S9 down to S2 as A and B. Then our opcode is these 2 switches with these 2 buttons right here. So right now we're in the AND gate, so let's just test all zeros. As you can see, it's 0. And if we test all ones, it outputs F as it's supposed to be, 15. And then let's say we have 7 ANDed with 5. It should just output a, oh, that's not 7, that's my bad. ANDed with 5 should just be 5. And if we do 7, it should be 7.
Alrighty, so our next component is the OR bitwise. So it's going to be using the same inputs. So if I go ahead and switch it to the opcode for OR, and I do 0, 0, 0, 0 with 0, 0, 0, 0, I get 0, which is correct. And then if I switch it to 1, 1, 1, 1 across all of them, it gives 15, which is also correct. And if I do something like 3 and 13, 12 actually, it gives 15. Alrighty, I believe that one is working properly.
Alright, then our next component is the XOR gate. This is just 0, 0, 1, 0 counting from the left, so we'd have to hold down this button, and as we can see, it starts counting up when these are activated, but when B starts becoming 1s, it starts going down. So all 1s gives us 0s, all 0s give us 0s that we saw before, and then let's say we had something like this, 1, 0, 0, 1, and then all 1s for B. It will count these middle 2, which gives us 6 in decimal, which is what it has.
Alrighty, for our next component we have the inverse, and for this one our input is just A, so we're inverting A. So if I go ahead and select the opcode for inverse, and it's all 0s, which means it should be outputting all 1s, so it should be 15, which is F. So that one is correct. And then if we go ahead and make them all 1, it should output 0, which it does. And then if we do this, it would be 11, and the opposite of 11 would be 4. So that one is working properly as well.
Alright, that's all the basic logic gates out of the way. Now we have our adder, which, as we can see, counting from the left, is 0, 1, 0, 0 for our opcode. So now we're in our adder. This over here is our carry-in. As you can see, it works. So whenever I press it, it adds an extra 1. It uses A and B still. So let's just do, let's do 2 plus 10, which is this. 2 plus 10 is 12, which is what C is. If we add a carry-in, it gives us D, which is 13. Then if we add 6 and 11, if we do 6 and 11, we have this little LED here. I don't know if it really shows up. Right, there we go. Here's the LED. The LED shows that there is an extra bit that isn't being displayed on this right here. So this would be 6 plus 11, which is 17. So this is 16 plus 1 right here. This LED represents 16. Okay, and that's pretty much it for the adder.
Alright, next component is the comparator. And I'm going to go ahead and activate it there on the opcode. So we're comparing A and B, and if they're both 0, then the output is that they're even, which it'll give 1110, which is E in hexadecimal. So then if we switch to make B greater, it's going to output 1010, or no, 1011, which is going to be B. signify that B is greater. And if we make A greater, then it's going to output 10, 10, 10, which will be A. So the comparator is working properly.
Okay, our next component is even. It just checks if our number is even or not. So let me switch to that opcode. Right now, it's outputting an E, showing us that it is indeed even right now. Sorry. We're having problems with the wire here. So yeah, if it says it's an even number, and we're comparing with A here. So as you see, if we have, counting from the left, 1, 1, 1, 0, it's still an even number because that's 8 plus 4 plus 2, still even. But as soon as we turn on this bit right here, it turns to F, saying that it's basically false. It's not even. That's what F stands for. And if we do 9, that's odd, obviously. It's not even. If we do 1, that's not even. If we do 3, it's not even. But 2 is even, 6 is even, 14 is even. And that's pretty much all that the is even does.
Alrighty, and for the next component we have the is odd. So I'll go ahead and activate the opcode for that one. And is odd will output 111115 if it's even, so it'll give an F on the 7-segment display. And if it's an even number for the is odd, it's going to be 1001 and it's going to output O. And that one is working properly as well.
Okay, our next component is a shift right. This one has a few more things than just A being assigned to our first 4 switches. We have 2 more variables and a reset. Our reset is this button over here. Which one this is? Just this. Okay, so our reset's over here. Our load shift is what our most significant bit for B used to be, so it's just right here. So this just loads whatever A is. As we saw earlier, it was F. But let's load in B. Sure. Yeah, let's load in 12 or 11. Sorry, we'll load in 11, and what push value is this just determines if we're pushing in a 0 or a 1. Let's make that 1 for now. And then as soon as I take the load shift off, it will start shifting to the right. So it should give us 1101, then 1110, and then all ones. What would that be? That'd be 1101, which is 12, 13. Then we've got 14, then 15. So okay, I couldn't really see that, so let's just do that one more time. If we shift to the right, it will give us 1101, which is 13. Then it'll give us 1110, which is 14. Then it goes to 15. And there you go. It does it that, and then we have a reset button over here, resetting it back down to 0 as well. And as you can see, it still pushes to the right with the push value of 1. And just to see that the push value of 0 works, there you go. Let's actually retry that one. When it is F and we're pushing to the right, zeros, it should be 7, then it should be 7, and then it should be 3, and then it should be 1. All the way down to 0. And then if we start pushing in 1s, it should be 8, then it should be 12, 14, 15. There you go. So as we can see, the shift right works.
Alright, so next we have the shift left. So if I go ahead and activate the opcode, our load shift is going to be SW5. So if we push that on, it should load a value. And
Yeah, need a value.
yeah, it's loading 0 right now, which is what it should do, right?
Mm-hmm.
Okay, so if I change this to 1,
That's not good.
is this the right opcode?
Oh, it's because you had the wrong button there. There you go.
Okay.
Sorry, we had the wrong switch activated there.
Shouldn't it be? How do we get it to shift now?
You just turn off shift.
Okay, so then from there it should count upward. Okay. And then if we change the push value from 0 to 1, so for our first test case, or for another test case, I mean, we're going to do the load shift at 0 and the push value at 1, and it should go 1, 3, 7, 15, which is F, which it does. So that one works. And if we do another push value, or another test case where we put the load shift to 1 and the push value to 1, and we set our A to 1, 1, 1, 0, and then it should go from E, or 14, which is E, and then 13, D, A, B, C, D, E. Yeah, and then 11 should be B, and then 7 and 15, F. So D, B, 7, F. So that one works as well. And then for another test value, we're going to put the load shift at 0 and the push value at 1. We can switch it to 0 this time. And then press reset. Or we can load in 15 and then switch it so that it runs. I believe that's good.
All right. Next is our bidirectional PIPO shift register. This one is just going to be able to shift both ways. The opcode for that is 1010, counting from the left. So here's how you activate it right there. It's just loading in 15 right here. Because the load shift is still the same button, it's whatever B3 was, and that is SW5. Then we have on top of that a direction because it's bidirectional. This is labeled to SW4, this switch right here. And then we have a push value, which is still the same switch, SW3 right here. And reset is again still this button right here on the right. So as you see, bam. So we're loading in 15 right now because A is all ones. Let's say we're shifting to the right with a push value of 0. This will give us this will give us 7, 3, 1, and then 0. So 7, 3, 1, and then it goes down to 0. Then if we load that back up again, and then if we turn on our push value, this should just say F, because we're just pushing in ones to something that's already 1. Doesn't matter which direction we're going as well. Then let's say we start at 0, and then we're pushing to, let's push to the left here. So our direction is 0, which means we're pushing to the left, our binary number. And so this should go 1, 3, 7, 15 once we reset. So 1, 3, 7, 15. Let's say we start at 1, 0, so 9, 1, 0, 0, 1. We're shifting to the left, and we're pushing in a value of, let's say 0. Let's say we're pushing in zeros. This will go 2, then it will go 4, then 8, then 0. Sorry, that was the wrong button. 2, 4, 8, 0. There we go. So as you can see, our bidirectional PIPO shift does in fact work.
So our next component is the bidirectional counter with an input value. So I'll go ahead and show you it counting, starting from 0. And right now I have the direction as 0, so it's counting backwards. So counts backwards all the way from 0, it would go to 15, and then all the way down, back down to 1 and 0 and 15 again. So you'll see here from 0, it should go to F. And then if I change the direction to the other way, it'll count upwards. And if I put an input value of 10 and push my preset, and then keep going, and it should count upwards again, so all the way to F, and then back down to 0. And we can reset it whenever we want as well.
Okay, and that's all the required components. We also made a Johnson counter and a shift rotator. So I'll describe the Johnson counter here. It's just this opcode 1100 counting from the left. We have a lot of the same things, so our direction is marked to this switch right here, SW4, and then our preset is at SW2. So as we can see, if we want to put in 9, for example, we can put our reset and it rolls it back to 9. Then we have a reset over here, which resets it back to 0, which overwrites the preset, but obviously if I take my finger off, it will go back to 9. And what this will do is it'll wrap, well, it won't wrap, it will take the inverse of our lowest bit, put it back to the most significant bit. And so right now we are going, I believe forwards is what this is. Actually, let's just put this back down to 0. So we're going forwards, which means this should be 8, and then 12, 14, and 15. We're not going forwards, we're going backwards. That's my bad. So this is backwards. When direction is 0, we're going backwards. So this will loop our most significant bit back down to our least significant. So it will go 1, and then it will go 3, then it will go 7, then it will go 15, all the way back down. So 1, 3, 7, 15, then we'll go E, C, 8, and then down to 0. We'll just keep doing that forever. As you can see, we reset back to 0, and then if we want to go to upwards, that would be this one right here. So we'll start counting the other direction. So as you can see, our Johnson counter does in fact work. Okay, and then our next component is the shift rotator. This operation code is 1101, reading from the left. So this is it right here. What this will do is it will just rotate well, right now it rotates off, but it will rotate our bit and wrap it around so that it will kind of loop around the binary number. Our rotating option is right here at SW5. Our direction and preset are in the same switches, but whenever I have rotate on, it should start rotating, but obviously we don't have a number in there, so let's put in 9. So whenever 9's in here, we'll be shifting to the left, I believe, since our direction is 0. And so what this will do is, after this, it will give us 1100, counting from the left, and it will give us 0110, and then it'll give us 0011, and then it'll go back to 9. So that would be 12, then 6, then 3, then back to 9, which is just the preset. Okay, I obviously went the wrong way again. That's my bad. Here, this is what I was talking about before. So go 12, 6, 3, 9. And as we saw, the other direction works the exact same way, just in the opposite direction, like it should. We have a reset here, which, as you can see, works correctly. And we can load whatever value we want into here. Like we can do 15 if we would like. But whenever we rotate, obviously it's not going to change. But as soon as we load in a different number, it will start rotating, and it will just do this indefinitely until we reset it back down to 0. And that is our 4-bit ALU. We have 12 components, and then our 2 extra credit components. But other than that, that's it. Thank you.